Welcome to Swell Academy. Today we're talking about adding and subtracting fractions with like denominators. One thing I just want to point out before we get started is just kind of show you an example, give you a visual of what we're dealing with here. So we have let's say two people, and they have a certain amount of change. And let's say one person has 2 quarters, a dime, a nickel, and a penny. And another person has 3 quarters, a dime, and a penny. And I ask you to add up the amount of quarters each person had. And what you would have to do is say, okay, well, you would look to see which of each person has the same amount of quarters. So basically, this person has 3 quarters, and this person has 2 quarters. And that makes sense. Altogether, it has 5 quarters. And what you've done is just add the pieces that are alike. Well, in actuality, what you did is you added the fractions that are alike. And basically what changes and what money is a fraction of $1, right? 4 quarters make up $1. And that whole idea of adding fractions with like denominators is just basically like adding change based on adding the same quarters or dimes. So for instance, if I wanted to add or take a look at how many tenths or 1/10 each person had, I would say, okay, they have a tenth here, which is a dime, and they have this person has 2/10 here. So I could actually add up the amount of tenths each person had and call it 3/10. And I could have done the same with the quarters, saying, okay, this individual, person 1, has 2 quarters, and this person here has 3 quarters. Altogether, they have 5 quarters. And if we see here that 4 quarters make a whole, and this is made up of 1, 2, 3, 4, 5 quarters, well, I have 4 quarters here, plus the 1 quarter left over. This is my whole plus that 1 quarter. So I have $1 whole plus the quarter. And this is where that mixed number, what we call a mixed number or a whole number with a fraction, comes into play. That's why I call it mixed, because it has a whole number mixed with a fraction. Now let's just take a look a little further here, and let's take a look at, just maybe without the visuals, a simple adding a fraction problem like 8/5 plus 3/5, let's say. Now, the only reason I could work with this without having to change anything is because the denominators that I've been given, this bottom piece, is the same. That's real important. If it were different, if I were given 8/3 plus 3/5, I would have to add more steps, and we'll show that in another video of how to make these the same piece. So right now, if we're just working with like denominators, that's not something we could do. And what I'm going to do here is add the tops. So I have 8/5. So basically, if I break this down, I have, this may take a second, but I want to show you. I want you to see that I have 8/5. That's what this is saying. I have 8 quarter pieces. I have 8 of these 1/5 of the whole, plus 3 plus 3 more 1/5. It's just good to see it that way, see it visually, and that gives me 11/5. Now, we have this idea again where we have a bigger number on top than on the bottom. Now, we know if I have all 5 of these pieces, right, if I color in these other pieces here, Oh, got a marker coming in. And I have all 5 pieces. I have 5 out of 5. That color's run out on me. I have 5 out of 5 pieces. So what amount of holes do I have represented here? Well, I have that 5 out of 5 here, plus 5 out of 5 here, plus a 1/5, right? Because if you're looking, if I break this down, I could break down this 10 into 11 and a 1, and then I could break it down into a 5, 5 and a 1. And so altogether I have a hole, 2 holes, and a 1/5. And this is how we're adding like fractions. Now let's just move and take that right into subtracting like fractions, where I'm looking at something like 5/8 minus 1/8. Now same rules apply, simple. Denominators are the same, so we're good. We're good to subtract here. We're simply just gonna do 5 minus 1 over 8. Sometimes I show this where I'm doing the arithmetic on top and leaving the denominator, and I get 4 over 8. But let's see what's happened here. This 4 over 8, which could be shown like this, 4 over 8, which is 4. If I break a hole into 8 pieces, right, this can be what we like to call reduced. So it could be shown in bigger pieces. So basically I could take this and break it into quarters and say I have 2/4. So here I've taken 4/8. We didn't lose anything, stays the same, but I've just represented bigger pieces, and I could do so again by taking another pie here, coloring in the same amount of space, and saying that this is 1/2. This and this being the same answer, equally correct. And a lot of times on any testing, SAT, they're looking for this reduced answer. So you may get this, but have to find this. Another way to do that is to take your 4/8. There's many ways to reduce fractions, and I'll show that in another video. 4 divided by 2, that's how we get to 2 over 4. We see 2 and 4 can be divided by 2 again, and we get the 1/2. Or you could have even noticed that the biggest number that goes into 4 and 8 is 4. 4 divided by 4, 1. 8 divided by 4, 2. And that's how we get our answer, 1/2. I think another thing to consider while you guys are doing this too is that idea of when adding and subtracting fractions, especially subtracting, you may end up subtracting a bigger number from a smaller number, okay? Now, when you're subtracting, you're talking about difference. So if you're looking for the difference between 10 and 15 here, okay? So basically you're saying 10 plus a minus 15. What you're saying is, if I'm starting at 10 and I'm going a difference of 15, and subtraction being to the left, and I go 10 to 15, well, I have to go another 5, I would end up at -5. So think about it like this. If I just looked at 10 and 15, what's the difference between these two numbers? Well, 5, right? 15 is 5 more than 10. And what do I have more of? I have more negative. And I've shown this a lot when we do our algebra 1 step and whatnot. And that's where the -5 comes in. And you end up with that -5, don't forget, over 13. The answer isn't just -5, it's over the 13. And you're basically showing this difference here. You're doing the 10 minus a 15. It's showing the difference between 10 and -15 is a -5. I hope this helps. We're going to be moving on to mixed numbers next, adding, subtracting that, converting them. This is a good start. I know I kind of go into it a little bit, but I do want to show you guys the visuals. If you miss anything, don't forget, you could go back. And I'll be adding other videos, so if you subscribe, you'll see when I post those. Thanks for stopping by.